Okay, so I want to continue on today with still section 7.1, but the last 2 days you've been working on writing a formula from a name. Today we're just going to do the exact opposite. We are going to write a name from a formula. So if we see a chemical formula of an ionic substance, we can name it. Okay, so I'm going to be working with your notes, okay, and your common monatomic ion sheet and your common polyatomic ion sheet, okay, to go through these examples. And very similar to what you've done the last couple of days, you have a homework assignment of naming those ionic compounds for tonight, okay? And then we're going to move on to naming molecular compounds, which is a little bit different, and writing names there. Then we get into naming and writing formulas for acids, okay? And then we'll kind of put everything together, and we'll do a practice test, and then we'll do a final test as well for your nomenclature and your naming. It's simply going to be a certain number, probably around 15 formulas that you write names, and about 15 names where you write formulas. And that'll be it. Okay, so let's take a look at your notes. I wanted to do the Word document today so I could type on it instead of trying to write, because we're writing names now. It's a little bit longer, and write like I did previous. So that's not what I want. I want this right here. Okay. So here is your notes on naming ionic compounds. And it's a pretty simple method for writing a name for an ionic substance. Okay, there's just 2 steps. Okay, the first one is name the cation. That's always going to be written first. Now, the only little difficult part with that is it says use a Roman numeral if the cation has more than 1 charge. So for these particular, let me go to the monatomic ions. For these 10 substances, when you write the name, just as you see here, you have to put the charge of the particular ion in parentheses. Okay? Conversely, if it's one of these that only has 1 charge, you do not have to use Roman numerals. Okay, that's called the stock system of nomenclature or of naming. So the difficult part is with these, you actually have to figure out what the charge is so you can name it correctly. You do that by looking at the anion. Okay, the anions, regardless of it being monatomic or polyatomic, they always have the same charge. So you can figure out the charge on the cation from the anion. Okay, so let me jump back to our notes. Okay, so name the cation first, use a Roman numeral if the cation has more than 1 charge, and then you name the anion. So it says here at IDE ending if it's a monatomic ion. That's already like that on your ion sheet. It already has the IDE, and then name the polyatomic ion. It's just as it appears on your polyatomic ion sheet. And remember, for your naming test, you will have those 2 sheets available to you, whether you have them open on your computer or iPad or whatever, or if you print them out and have them right in front of you. You can do either one. Okay, so let's look at this first example. Okay, here's BaCl2. So Ba, if we go back to our ion sheets, here it is right here, barium, it's a +2. It's always a +2, so you don't need a Roman numeral in the name. Okay, and then Cl is chloride. Now, the only reason there's 2 chlorides is because, as you remember, writing your formulas from your names is because barium's a +2. So we don't have to include that in the particular name. Okay, so let me jump back here. So first you would name the cation. That is barium. Okay, doesn't need to be capitalized. I got the automatic capitalization there. Okay, and then we'll name the anion, which is chloride. And that's it. Okay, you just name the first cation, and then you name the anion. And if you were given this and what we did the last couple of days, if you were given barium chloride and asked to write the formula, you would write Ba plus 2, Cl minus 1, crisscross your charges, and you would get BaCl2. That's a good way to check to see if what you're doing is correct. If you write a name, take that name and go back to the formula and make sure it matches up. Okay, let me tab over here to this next one. So here's this next one, NH4BrO3. This contains 2 polyatomic ions. So let's look those up. Okay, here's your polyatomic ion sheet. Here's your NH4, that's ammonium. Okay, and BrO3, that's right there, that's bromates. Okay, so we'll name the cation first, ammonium. Okay, and then we'll name the other polyatomic ion next, bromate. So NH4, BrO3, plus 1, minus 1, already equal and opposite, 1 of each. Okay, now let's take a look at this third one. Fe, the quantity OH taken twice. Okay, so this iron happens to be one of the metals that's multivalent or that has more than one charge. So we have to figure out, it can be one of 2 things. If we look at our monatomic ion sheet, it can either be iron 2 or iron 3. It has to be one of those 2. Okay, so it's with 2 OHs. So if we look at OH, that's right here, that's hydroxide, and it's a minus 1. So if you have 2 of those with your iron, that means that your iron has to be a plus 2. So when we name it, we have to name it iron, Roman numeral in parentheses, 2, and then name the polyatomic ion, which is hydroxide. Again, let's go over how we knew this was a plus 2. OH is a minus 1, okay? And you have 2 of those to give you an overall minus 2. The iron has to balance that out in a correct ionic formula. So the iron would have to be a plus 2. Iron can only be a plus 2 or a plus 3. If this was Fe, the quantity OH taken 3 times, then it would be a different substance. It would be iron 3 hydroxide. So that's one thing to keep in mind. Okay, let me jump down here to this next example, Cu, C2H3O2. Now this whole thing, and we did use it yesterday in our last lesson, is acetate. You can write it one of 2 ways, CH3COO or C2H3O2. Okay, it's a minus 1. Now copper, again, another one of those 10 metals that we have to use a Roman numeral because it can be a plus 1 or a plus 2. So if we look at those here, okay, there's your copper. It can be a plus 1 or a plus 2. Here's your acetate right here. You can write it either way. You don't have to write it both ways. You can write it either way. So it's a minus 1. So if our formula is Cu, C2H3O2, so we have 1 Cu and 1 acetate, that means that this has to be a plus 1 and this has to be your minus 1. Okay, so we would name that accordingly. Copper, Roman numeral 1, and then acetate. Okay, again, it's a 1 because you have one of these. If you had more than one of these, it would be in parentheses with a subscript outside. The only other thing it could be would be Cu, then the quantity C2H3O2 taken twice, and then it'd be copper 2 acetate. Okay. All right, let's look at this next one, KMnO4. So here's K. Right here, always a plus 1, so we don't have to worry about what charge it is. We're just going to name it potassium. Okay. And then MnO4, here that is right here, permanganate. So we just put those 2 together to give us a name. Potassium permanganate. Okay, there it is right there. one other thing, this copper isn't capitalized. If you capitalize, it'd be fine, but it automatically capitalizes that. Okay, so I'm going to back that up a little bit so I have more room to write this next one. And our last one for today, Zn3, the quantity PO4 taken twice. Okay, let's find those. Here's zinc. Okay, even though zinc is a transition metal, it's always a +2, so we do not need a Roman numeral. Okay. And then our phosphate right here, PO4 minus 3, is phosphate. Okay, it's phosphate. So when we go to name that, okay, we have zinc and then phosphate. And that's it. And again, if you would be given zinc phosphate and you were asked to go to this formula, you would write Zn plus 2, PO4 minus 3, 2 here, 3 there, 3 zincs, 2 phosphates, and you'd come back with that particular substance. Okay? So again, I think there's 21 on the sheet for you to write out. Probably, again, the most difficult thing is determining for those 10 what the charge is. Make sure you use the anion to figure out what the charge is on the cation. If it's something like barium or potassium or zinc, you just have to name it. You don't have to even worry about what the charge is. You don't have to figure that out. Okay? Well, I hope that helps with writing names from formulas. Okay, see how you can do on the homework.